Our next speaker is Yahel Ben-David, is the founder and CTO of AirJaldi, currently also a PhD student in the Department of Electrical Engineering and Computer Sciences at the University of California, Berkeley. His research focuses on affordable long-distance wireless networks with an emphasis on security. Before shifting his focus to social entrepreneurship, Yahel co-founded the Xpert Group in 1993, a multinational security and continuity solutions provider. Yahel designed and led the technical setup for some of the world's largest ISPs, consulting to many Fortune 500 companies, and supervised a large number of security projects for governments and top .com leaders. Following the sale of his Xpert Group holdings in 1999, Yahel has been living and working in the Indian Himalayas, Dharamsala, where he harnessed his professional expertise to support a wide range of social causes and projects in the ICT for D spheres. Yahel is the founder of two Dar es Salaam-based nonprofit organizations, AirJaldi and the Tibetan Technology Center, TibTech. As a part of his doctoral studies, he leads AirJaldi's R&D in collaboration with UC Berkeley's TIER Group and De Novo Group. Yahel brings over 20 years of extensive, hands-on, diverse technical experience, as well as a wide network of leading experts and professionals. Mr. Yahel Ben-David.
Thank you, Amojin. And thank you for organizing this beautiful event. So, I'm losing my voice, so with the help of my magic potion, I might get through the 18 minutes I have. So, this map shows the density of internet connections across the globe. The brighter the pixel, the more connections. Very sadly, it's a very, very dark map. The majority of these dark areas are poor and sparsely populated markets that cannot be served profitably using the traditional technologies. In the talk today, I'll share my thoughts on how can we accelerate the reach of internet penetration to brighten up those darkness. So I've spent most of the 90s designing and building internet service providers and data centers across the globe. And then in 1998, I got a call from a friend who was working with the Tibetan government in exile in Dharamsala, a little small town in the Indian Himalayas. He asked for my help with internet connectivity, and he said there's great trekking in the area. So I came over for a short visit, and I stayed for 10 years. I don't know if I could climb this peak today. I mean, I gained a little bit of weight, but it was fun when I could. I therefore sold my shares in a company I've co-founded and returned to Dharamsala, and my work focus was internet connectivity to rural communities. This actually continues to be the focus of my work today, and in the last 3 years from here in Berkeley. And you know, these old photos, I don't know if you remember the days of coaxial Ethernet hubs and the 1200 baud modems that these used to get burned every often, and we had to replace them. That's why we have such a big pile. So at the time, there were many local organizations in Dharamsala that already used computers. They were desperate for internet access. But the only one that could afford the very expensive and painfully slow internet connection, there was only one that could afford that. And many of those NGOs worked in collaboration, and they were willing to share the costly links of the satellites. But they were located somewhat apart from each other, and therefore sending floppy diskettes with motorcycles became the dominant form of information exchange. I then started searching for solutions for getting the many organizations interconnected and for getting better internet bandwidth from the faraway cities. It quickly became clear that the problem is not unique to Dharamsala and not unique to rural India. Therefore, the solutions would be applicable and relevant to a much broader population, and that was a very strong motivation to work further. Let's go a little bit into the history of this technology. So in those days, if you had a laptop when landing in India, you were a criminal. Most laptops, already back then, had embedded Wi-Fi chips in them, Wi-Fi radios. And using any radio waves without a license was illegal. In fact, even the possession of such a radio equipment could get you in trouble and could get your laptop confiscated. And it's simply because the use of the wireless spectrum, the airwaves, was reserved to large corporations that could afford the license fees. Fortunately, this is no longer the case. Wi-Fi radios began sneaking into laptops and other devices a little over 10 years ago and are now virtually in every computing device. Policymakers had to allow this and allow people to use them freely. The really cool thing about Wi-Fi is not the technology itself. It's the fact that it's quickly getting deregulated throughout the world. Deregulated means that we can use it without a license, and that's a very big shift. The deregulation of Wi-Fi is driving innovation, which in turn drives adaptation, which drives prices down, and making this technology ubiquitous and affordable everywhere. Early in 2005, India finally deregulated the use of Wi-Fi, and to me, that created AirJaldi. That's what symbolized the start of AirJaldi. For the first time, we were free to help ourselves and experiment with the wireless technology without dependency on the incumbent telephone companies and large corporations. I therefore began to set up those improvised wireless devices on the rooftops of the organizations in Dharamsala. I marked the wireless signal AirJaldi. Jaldi means in Hindi fast, and that was to suggest that the days of painfully slow speeds are over. Within a few days of Wi-Fi deregulation, we had a small network of interconnected organizations, all sharing a satellite link to the internet. This network has been growing ever since. We've learned to use Wi-Fi for making very long-distance wireless links. The same low-cost silicon chips that are embedded in routers, in the home routers that you see, if connected to directional antennas, and with some innovative software modifications, allowed us to link stations hundreds of kilometers away. And with pretty fast bandwidth, faster than what most broadband connections allow even today. I've then started ordering piles of these home routers and ripped them apart in order to build those outdoor units like the one, like this one on the left. In the top center photo, you can see my wife. She's talking on a fancy IP phone to her sister in Israel, and over a network that we built ourselves. And that was a very good way to test the network. If she cannot make the phone call, we have to fix something. Let us jump ahead 6 years. Present. We've successfully installed hundreds of wireless links, and we serve thousands of happy users, and we're growing fast. In fact, I think since I left India, things are growing much faster, and we now have presence in multiple states within India and network academies, and it's really a wonderful work that the teams on the ground are doing. They've learned to overcome complex operational challenges, refine the solutions, and demonstrate a sustainable business model. But not less important, our work inspires many rural entrepreneurs, including local competitors, and they all follow our path to serve their communities, and we're very, very proud of that. However, if we return to the dark map of the world, the whole of AirJaldi would not even count for a small, dim pixel. We're a small drop in the ocean. We need to distill the lessons we've learned from AirJaldi and apply these on a global scale. Let us look at some of the remaining challenges ahead of us. So, in some detail, those are the 3 challenges that I think are key obstacles for rapid diffusion of our solution on a global scale. I'll start with a rather simple problem, yet one which demonstrates the need for out-of-the-box and creative thinking about the solution. In addition to presenting this this first one, I'll give a non-technical overview of the technology that we use. So as we build those long-distance Wi-Fi links to reach further into the rural areas, we've learned that the only thing that limits the distance is line of sight. At the same time, we already also realized that the world is round. And that's actually a very serious problem. In order to overcome that problem, we need to erect very high towers to overcome the curvature of the earth. These towers are substantially more expensive than the gear they hold. And the real estate for these towers is costly, and they often require licenses that are difficult to obtain, and they need to be serviced, and they are dangerous, and finally, they're also ugly. So, but most of all, can we really expect rural entrepreneurs in, small businesses to erect towers, to go around erecting towers? I don't think so. So the question was, can we do long-distance Wi-Fi without towers? Yes, we can. Let's use natural towers, a mountain, like that. So we place a small Wi-Fi relay on the mountain to connect between the city, where the internet bandwidth is available, and the rural area, which we wish to serve. And there we go. Yeah, no, okay. So we can't always expect a mountain to be conveniently located right between the 2 points we want to connect. But how about that? Remember, we can do hundreds of kilometers. So a far mountain is just as good. And unlike towers that typically give us about 10 kilometers or less, with the mountain we can do hundreds of kilometers. It only depends on the height of the mountain. So the question is, would this methodology allow us to cover the whole planet? I don't think so. But then how many plain areas exist that span hundreds of kilometers and have people in there, living in the middle? Not too many. I think so. So no more ugly, dangerous, and costly towers, and real estate on mountaintops. That's traditionally a lot cheaper than in populated areas. But there are more problems. So there's no power on mountaintops traditionally. So, right, but our gear is so energy efficient that it can be powered by solar power or a small wind turbine. So, in fact, we also found that often we need to use solar anyways, because the power is so bad, the grid power is so bad. Even in the cities, we still need to use renewable energy. So the photo on the right actually shows a mud house with slate roof. And I don't know how many of you walked on slate roof recently, but I can tell you I cannot do it anymore. I mean, that's for a very lean employee. And so this is what it looks. This is what our mountaintop relays look like. That's, by the way, over there is a roof of a Hindu temple, and a lot of times we find those on mountaintops or hills. So they become a very good partner for installing those mountaintop antennas. Let's see this example, for example. You see in the foreground our small mast, and behind it is this huge government-owned tower. So our small relay has substantially more bandwidth than that of this whole monstrosity behind it. And we power it with only a solar power, and we don't truck diesel up and down the hill, only up the hill to feed the two huge generators. The puzzle is not complete, however. These mountaintop relays are great, but the underlying technology based on Wi-Fi does not allow us to serve multiple subscribers at great distances. We need to still make some software changes to the existing equipment in order to solve that. Our research group here in Berkeley, TIR, is working on that problem, along with some additional technical challenges that I won't get into. You can Google for AirJaldi if you want to get into more technical details. Okay, let's go to challenge number 2. Let's talk business. So the typical model today, in the small wireless internet service provider, or as we call them, WISPs, they need to buy upstream bandwidth, and they have to buy it from a large incumbent ISP. And, that's all great, but what happens, if the WISP grow to serve subscribers within the coverage area of the incumbent. It leads to competition. Competing with your supplier is not a healthy thing, and it's going to eventually hurt the small player. Additionally, although most countries have deregulated the use of Wi-Fi, it's still very common that provision of internet services require costly licenses. And those licenses are typically unattainable by small entrants. So this again makes us stumble upon the policy and regulatory issues. Can we solve this? I think an interesting solution would be to decouple the wireless infrastructure from the internet services. The rural operators should only set up and operate a network of smart wireless pipes. The wireless infrastructure would link subscribers to existing internet service providers, and subscribers will be able to choose their ISP. And the rural operator will only need to manage the wireless infrastructure, and they become internet neutral and does not require any licenses. And furthermore, they don't need to compete with the incumbents. Instead, they become valuable business partners to them. So we've seen some of the advantages, and it solves the need for a license and diffuse the competition. But in addition, by delegating the user support, the customer support to the larger ISPs, the small operator can really focus on maintaining the wireless network alone. This model would also simplify human resource issues, especially training and local capacity building, because training employees to deal with an outdoor antenna installation is much simpler and less time-consuming than training of network administrators and system operators. Again, the technology is the missing piece. This separation, the separation to allow decoupling of the wireless infrastructure for internet services, is not something our networks can handle at this point. Once again, here in Berkeley, the TIR group began working on these software solutions, and we tied them to the next challenge, the last challenge of network management. So network management is really hard. This is the network management center of an ISP in India. And I don't think it's likely to see this kind of operation in rural Dharamsala. And, this is what our network operation looks like. In fact, this is an old photo. It looks somewhat more impressive today. But, the network is just growing faster than we can grow our support teams. So the small WISPs, the small wireless internet service providers, cannot afford the highly trained manpower required to master these complexities. And once an employee gets well-trained, that person would move to the city where salaries are much higher. So much too high for the rural operator to sustain. So as we suggested earlier, the decoupling of the business models, decoupling the traditional ISP functionality from the wireless infrastructure would help a lot. But still, even just the management of the wireless networks remain a very, very complex issue. We need to think much bigger. We need to think on a global scale. Remember 10 years ago, it was pretty uncommon, even for users here in America, to install their own home router. We used to call the serviceman for everything. Today, not anymore. Most people will install their own router at home. I think this is exactly the kind of change that needs to happen to rural networks, rural Wi-Fi networks. There's a lot of work and very big systems behind that thing to enable this simplicity. And that's exactly the kind of effort we need to focus on. So I'm not going to go into great detail about this slide. It's getting too complicated. All I'll say that we think that we can harness the strengths of cloud computing to address these issues, along with some innovative new technology that is actually targeting data centers. I think coupling them together will allow us to apply this to the new challenge of managing those large Wi-Fi networks. I think the solution should offer a lot of levels of simplicity for many stakeholders. We have, from the end user that is concerned with her own rooftop device, to partner ISPs, to regional support staff or operation centers. All those stakeholders need to have access and simplicity in accessing these devices for billing, for other customer services, and so forth. So this is a pretty big task ahead of us. And it calls for serious work. I'm almost done. As expected, it gets networking researchers in academia really, really excited. And here in Berkeley, work has already begun. And, you know, for this work, the AirJaldi team from rural India should really lead and guide the scientists. And I find this really an interesting collaboration. Let me conclude with rephrasing the problem. Making this map brighter is going to take a lot of work. The work of AirJaldi demonstrates a viable solution that we should refine and replicate. We need to distill the experiences of AirJaldi's bottom-up approach and begin a global process of inspiring local entrepreneurs while providing them with the tools to simplify their work and overcome the obstacles in their way. I hope you also got a little bit inspired through this talk, and we really need all the help we can get. So please contact me if you want to play some role in connecting the next billion people. Thank you very much.